Hello everyone, this is Team VIKRANT and I'm the team lead Patman Karnataka. Our problem statement is SIH 25034, which is to make an AI-based internship recommendation engine for PM Internship Scheme. Now, the problem seeks to build a very simple AI-based recommendation system that will provide internships that are best for the candidates. And coming to the problem resolution, existing portal provides only static filters. And on top of that, it fails to capture user dissatisfaction or skill location trends. So our solution provides the combination of filters, feedback, machine learning, so to make sure the personalization is done in a perfect manner. And coming to the unique properties of this solution is that it will take the dynamic way of providing internships. Continuous learning of the data is done. The model will always evolve so with the data. And this also saves a lot of time. So being the lightweight model, so the unique value propositions of this project is that the solution takes dynamic feedback driven personalization for every search. This builds trust, satisfaction, and engagement. And my team will carry on the implementation details.
Now I'll be talking about the front end of our solution. So the main role of the front end is to um, provide user-friendly and accessible interfaces so that they can be used by any kinds of users, either it be low literacy or high literacy. And also we have focused on mobile first approach so that the students or users who do not have access to laptops can also access this solution with their mobile phones. And the key problem that we found was accessibility. So users can fill the form either by typing or by choosing the options. But here our uniqueness is they can also fill the form with their voice. Here we'll be having two icons. One is speaker and the other one is mic. So the speaker icon allows the user to listen to the label in English or in their preferred language. And the mic icon lets the user to give the input with their voice. So for this, we have used the Bashini API, which handles text to speech and speech to text translations across 23 Indian languages. So it accepts wide range of users across all over India. And the front end mainly contains two pages. One is home page and the other one is internship details page. So the home page contains two divisions, one having the preference form and the other one is list of internships. So when the user is selected, the top 5 internships for the particular user will be displayed. And on clicking each internship card, it will open up the detailed description about the internship, and the user can apply for the internship by redirecting to the PM internship portal. And also for the front end, we have used React.js, and we have handled all the edge cases like error states and loading states, so that the system would never crash even if the network of the user is slow or if the API fetch has been failed. And also we have integrated many icons so that it improves accessibility to a next level. And now Amrita will be talking about the flow of the system.
Coming to the recommendations our system provides, our system mainly provides internships to the users based on two key factors. One is based on user satisfaction, and the second is the acceptance rate. So, as my friend Ramya already told, the user can provide preferences through text or through speech. The preferences we collect over there are mode he wants to work in, either remote or on-site or hybrid. And the second is the preferred location of the internship he wants to work in, the preferred benefits he wants to have from the internship, the sector he wants to work in, and the role he wants to work in. So based on all these preferences, we give a preference score to the internship so that out of all the internships which are more likely to the user are provided to the user first. And the second thing we do is the acceptance rate. So an internship that is provided to the user must be such that he is guaranteed selected for the internship. So this we do using a ML model. So to do this, there are a lot of internships. First, we thought of reducing the internship space. So firstly, we remove the internships that the user is definitely not eligible for. The eligibility filter, we take the gender of the user, the age of the user, the minimum qualification the internship wants the user to have, and these eligibility filter only gives the internships that the user is definitely eligible for. And in the eligibility filter, we have also added the skills parameter. So in this, the skills that are required by the internship and the skills user have. Based on these two things, we calculate the match. So we set a threshold. If the skills match is less than 0.3 or 0.2, the internship is more unlikely to be given to the user. So here we also remove those internships. Now the internships that are out of the eligibility filter are definitely the internships that can be given to the user. And now we calculate the score for each internship based on the that will be given to the ML model. So from the ML model, we get the scores for each internship, which guarantees the acceptance rate for the user. And the second one, to improve more personalized suggestions to the user, we have involved a feedback system. So in this feedback system, based on the previous rejections user gave to the internship, what are the internships that user have not selected previously, are given a negative score. Now, all these preference score, regression score from the ML model based on the past selected similar users, and the negative regression score are normalized, and the top 5 internships are listed out to the user. If the user is not satisfied in such a case with the top 5 internships, we also have a backup of another 5 internships from which the user can select from. So these 5 internships are like just a backup plan to ensure that the user is not dissatisfied only with the provided 5 internships, and the previous internships which he has not selected are given a negative score and updated in the feedback system. Now, my teammate Rishi will explain you about the ML model in detail.
Yeah, thank you, Amrita. So, coming to our ML model, at a higher level, what it exactly does is that it takes the new user's data and find patterns, compare him to previous applicants. Like it finds users with similar attributes, similar skills, similar GPS, experience, location, etc. At the same time, it also matches current internship to previous internships with similar requirements. Internships that require similar skills, same roles, similar companies, etc. The ML model then analyzes how well those similar users have performed in similar internships. Based on this, it predicts the probability of current user being selected for current internship. In other words, it doesn't just look at the user and internship isolatedly. It analyzes the patterns of historical data and generate a data-driven likelihood of selection. Technically, we achieve this using a logistical regression model that captures their gender, location, company, sector, whatever it may be. Categorical features like sector, role are one-hot encoded, and user skills, internship required skills are multi-hot vectors to be fed into our ML model. Finally, if a user, after all this, choose not to apply the top internships we have recommended, we'll try to capture their feedback and analyze it to understand where our ML exactly went wrong in predicting user the best internship choice they have. This feedback loop is then fed into our model again, so that from the next round of prediction, our model is more accurate and better personalized for the users. In practice, this allows us to provide students with the selection probability for each internship, helping the acceptance rate of students increase and the rejection rate of internships decrease. The system can also provide multiple internship at once and currently fully integrated to our Django backend, making predictions fast and scalable. The feasibility of the whole system will be taken up by my teammate Jitendra.
Let's talk about the feasibility and viability of our solution. Our system is a lightweight and scalable using a rule-based and ML-like design that runs efficiently for a large number of users. It makes use of existing candidate inputs and internship data already present in the PM Internship portal, making it highly practical. It is accessibility ready, supporting voice input, mobile-first design, and regional languages. With low compute requirements, it is cost-effective, and because it integrates seamlessly into the existing portal, it requires minimal backend changes. We have also analyzed challenges such as static filters, lack of student feedback, poor results for new users, and irrelevant recommendations. To overcome this, we introduce AI-powered smart filtering, capture feedback to improve results, match skills and roles using machine learning, show trending internships, and refine rankings dynamically. This ensures that our solution is not only feasible but also sustainable in the long run. Now, the impacts and benefits will be discussed by my teammate Rehan.
Yeah, now let's talk about the impacts and benefits of our solution. It empowers youth with internship choices that fit them, bridging the city-village gap through mobile and voice accesses. It reduces wrong applications, saving time for students and companies, while supporting national skill programs with an easy-to-use, scalable system. The benefits are equally powerful. More jobs and a stronger economy, flexible ways for students to earn money, better access to career opportunities, skill building for long-term growth, and steady support for families. In short, our solution creates a bridge between skills and opportunities, driving both personal and national growth.